So velocity triangles, see here in this diagram, this is outlet triangle and this is inlet triangle. This is braid shape, our Pelton wheel braid shape, top view. Okay. In that case, water impacting on this splitter means here, water impacting here, then water removing like that direction and this direction. Okay. So here alpha is 0. That's why, see, alpha is 0 and theta is 0. That's why your inlet triangle convert into single line. Again. And this is your Lm is u1 velocity and Mn is Vr1 velocity. And total is V1, that is called jet velocity at inlet. So water removing like that direction, tangent to this blade, Vr2 is the relative outlet velocity, phi is the outlet blade angle, U2 is the outlet blade velocity, VW2 wheel velocity at outlet, beta is the um, outlet jet angle, V up is the velocity of flow. All parameter we have discussed in first unit, only inlet triangle convert into single line. Why? Because our water impacting on this splitter is tangentially. Okay. Because our water impacting on this blade tangentially, that's why our alpha is 0 and theta is 0. That's why our inlet triangle convert into single line in Pelton wheel turbine. In that case, our water impacting radially, then our inlet triangle is present. But here, our water impacting on this blade tangentially, so our alpha is 0 and theta is 0. Is it clear? Because all this diagram is required for solving the problems. Total problems depend on this diagram. See, after that, draw tangent to the outlet of the blade, sorry, inlet of the blade, and this angle is called angle of deflection. See here. This angle is called angle of deflection. Or angle of deflection equal to 180 minus phi. 180 minus phi. So, see the jet of water from the nozzle strike the bucket as filter, which filter up the jet into two parts. So, this part of the jet glide over the inner surface and come out at the outer edge of the bucket. The splitter is the inlet tip and outlet edge of the bucket is the outlet tip of the bucket. Okay. See here, our water impacting on this splitter like that. Water removing in this way. This water is draw the tangent to make a angle of deflection. This is actual photograph of the Pelton wheel turbine blade. The velocity triangle at inlet we have a straight line. So VW1 equal to V1, VR1 equal to V1 minus U1 equal to V1 minus U. So velocity triangle at outlet equal to VR1 equal to VR2. So VW2 equal to VR2 cos phi minus U2. Here VR1 equal to VR2. See here, see here, mass of the water striking on this blade equal to rho a V1. We have calculated by impulse momentum principle force equal to rho a V1, VW1 plus VW2. Work done by jet on the runner per second Fx into U. So rho a V1 into VW1 plus VW2 into U, Newton meter per second. Power given to the runner by jet rho a V1, V1 plus V2 into U upon 1000, that is called unit is kilowatt. So work done per second per unit weight of water equal to rho a V1, VW1 plus VW2 into U, rho a V1 into G. So VW1 plus VW2 into U upon G, hydraulic efficiency equal to work done per second, kinetic energy of the jet per second. So KE of jet per second equal to 1 half mv square. So 1 half rho a V1, V1 square equal to 1 half rho a V1 cube. So see here, hydraulic efficiency equal to work done per unit weight of water, rho a V1, VW1 plus VW2 into U per weight of water striking per second. So rho a V1 after simplifying this equation, rho a V1 into VW1 plus VW2 into U. So rho a V1 into G. The final after simplification, VW1 plus VW2 into U upon G. So hydraulic efficiency equal to work done per second per unit kinetic energy per second. So kinetic energy of jet per second equal to 1 half mv square equal to 1 half rho a V1, V1 square. So final 1 half rho a V1 cube. So hydraulic efficiency we have discussed. Now after simplification, we are getting hydraulic efficiency equal to 2V1 minus U, 1 plus cos theta, so cos phi into U upon V1 square. So efficiency is maximum when condition for maximum efficiency. Differentiate hydraulic efficiency with respect to U and equate to 0, that is called condition for maximum efficiency. So 1 plus cos theta upon V1 square d by du in bracket 2u in bracket V1 minus u bracket complete equal to 0. So u equal to after derivative, after differentiating, we have getting U equal to V1 upon 2. So expression for maximum efficiency of Pelton wheel equal to 2 V1 minus V1 by 2 plus 1 plus cos phi into V1 by 2 upon V1 square. So after simplification, maximum efficiency, hydraulic efficiency equal to 1 plus cos pi upon 2. This is condition for maximum efficiency. So velocity at maximum hydraulic efficiency equal to V equal to U by 2. So Pelton wheel efficiency equal to C like that. This is Pelton wheel efficiency and this is speed ratio maximum. So in the diagram, V1 equal to some assumption there, V1 equal to for solving problem some assumption there, inlet diagram equal to V1 CV under root of tau GH CV is the coefficient of velocity and value range from 0.91 to 0.99. U equal to pi dn by 60. U1 equal to U2 equal to U. Alpha equal to 0 degree. Theta equal to 0 degree. VR1 equal to V1 minus U. VW1 equal to V1. Outlet triangle. So VW2 equal to VR2 cos pi minus U. So K VR1 cos pi minus U. K equal to VR2 upon VR1, friction factor. Mass flow rate rho a V1, we have discussed. Work done by jet per run, jet on runner per second. The work done equal to apex into U. So we have calculate power. Power equal to VW1, VW2 upon 1000 into mass flow rate into U per kilowatt. So hydraulic efficiency equal to mass flow rate into VW1 plus VW2 into U upon 1 up mv1 square equal to 2 into VW1 plus VW2 upon V1 square upon U. So maximum hydraulic efficiency we have calculated from diagram equal to U equal to V1 by 2. So we observe that maximum hydraulic efficiency of Pelton wheel occurs when the velocity of runner is half of the velocity of jet. So putting value U in maximum efficiency equation, we get 1 plus cos pi upon 2. So hydraulic efficiency, maximum hydraulic efficiency equal to 1 plus cos pi by 2. So for a hemispherical bucket, the deflection angle is 180 degree, hence pi equal to 0 degree, means equal to 1 or 100%. So see design of pattern wheel. ओमकार माईक ऑन करायचा नाही. ए ओमकार ओमकार
हॅलो.
हा माईक ऑन करायचा नाही.
हा हा हा.
Design of pattern wheel. Design of pattern wheel means following data is to determine diameter of the jet D, diameter of wheel capital D, width of bucket 5 into D, depth of bucket 1.2 D, and this is no num of bucket on the wheel, number of bucket on the wheel equal to total rate flow through the turbine per rate of flow. So see here, number of bucket on the wheel, how to calculate? Total rate of flow through the turbine upon rate of flow of water through a single jet of water through a single jet. So this is design parameter we have discussed already. V1 equal to CV under root of tau GH, coefficient of velocity in between 0.98 to 0.99. The velocity of wave U equal to pi into under root of tau GH. Value of the 0.43 to 0.48. Angle of deflection 165 degree, near about to 170 degree. The mean diameter of pitch diameter of the pattern wheel is given by capital D. Jet ratio, it is the ratio of pitch diameter of the jet m upon d by d. Number of buckets z equal to 15 plus d by 2d. So z equal to 15 plus 0.5 m. So number of buckets, it is obtained by dividing the total rate of flow through the turbine by the rate of flow of water through the single jet, that is number of jets equal to Q upon Q. So see here, working proportions of buckets, width of the bucket 3D to 5D, approximately 5D, depth of the buckets 0.8D to 1.2D. 1.2D means into diameter, 1.2 into diameter. So see here, dimensionless buckets, the minimum possible width of B of the bucket is approximately 2D, where D is the diameter of jet. This dimension is usually taken as 2.8 to 3.2D to avoid losses. Some prefer to take it as a 3 to 4D. The depth of the bucket T usually lies between zero point 0.8 to 1.2D. The height H of the bucket 2.4 to 2.8D. Other dimensions of the bucket are taken as below. E equal to 1.2D, F equal to 0.4D, G equal to 0.9 to 1, BI equal to 3 to 6 degree, and B outlet beta equal to 10 to 20 degree. So, working principle, working design proportions we have discussed, and this is some also according to directions, some working proportions there. Radial length of the bucket, axial width of the bucket, and depth of the bucket. So real equal to 2 to 3D and beta equal to B equal to 3 to 5D and D equal to zero point 0.8 to 1.2D. So diameter of jet equal to the velocity of jet out of nozzle is given by V1 CV under root of 2GH, where Vi velocity of jet, CV coefficient of velocity for the nozzle. Values rise between 0.95 to 0.99. D is the diameter of the jet discharged through the nozzle. Q equal to pi by 4 d square Vi pi by 4 d square Cv under root of 2gh. So D equal to under root of 4q pi Cv under root of 2gh. So speed ratio Ku of a Pelton turbine is defined as the ratio of the tangential velocity of wheel u to the theoretical velocity of the jet. This is speed ratio. U is our blade velocity under root of 2gh. We have discussed. Now, N is U is calculated by pi dn by 60. That is speed of the blade. So jet ratio is defined as the ratio of diameter of the runner to the reach diameter of the jet. So M equal to D by D. So design accept an important point of Pelton wheel. Summary of Pelton wheel design. Velocity of jet V1 equal to Cv under root of 2gh. Velocity of wheel U calculated by pi dn by 60. Ku calculated by U by V1 and jet ratio calculated by mean pitch diameter of the wheel D and jet diameter upon D. Number of jet calculated by total flow rate of water through turbine, flow rate of water through a single nozzle, angle of deflection 180 minus pi, angle of deflection 180 minus pi, number of buckets on peri equal to Z equal to 15 plus 0.5 m. So 15 plus 0.5 d by d. So governing of hydraulic turbine. This is governing mechanism of hydraulic power turbine, and after that characteristic of turbine. So here, after completing these 2 points, governing of mechanism of hydraulic turbine and characteristic of the turbine, after that we will complete this unit. So any doubt, any queries in this work done and efficiency of the Pelton wheel, please ask me. Any doubt, any queries? No doubt? So, any doubt, any queries, please ask me, all of you. Attendance link is open. Any doubt, any queries, please ask me, all of you. Avinash, are you there? Avinash? Hello? Avinash? So, let's start governing of hydraulic turbine. So, see, governing of hydraulic turbine means in case of flow of water is a water storage capacity. We have water storage capacity in our India in the dam. So using dam water for the producing the electricity. This water storage capacity is varies continuously, totally depend on the rainy season. So we are need to control the turbine speed or need to control our turbine rotate at constant speed. So here we have seen the governing. So we are doing controlling the speed of the turbine. The governing of the turbine is defined as the operation by which the speed of the turbine is kept constant under all working conditions. That is called governing. Means control the speed of the turbine in various different conditions. So, how to control the speed of the turbine? So that is various type governor control like that. So see here, see here, governing of turbine is necessary as a turbine is directly coupled to electric generator, which is required to run at constant speed under all fluctuation load conditions. Means in that case, your load is varied, your load is varied or different, your rotor rotate, you are required to your rotor rotate at constant speed. So that's why we are required to control the speed of the governor, speed of the turbine. Okay. So one notice for you, all of you, unmute your mic. All third year
Yes,
students,
sir.
unmute your mic. In next lecture, we have discussed governing of hydro turbine. So all of you unmute your mic. Abhishek, Atharva, Rishikesh, Kunal, Nikita.
Yes, sir.
Yes, sir.
So first question here, number of students doing various other activity. So any problem, those students? Because number of students unmuting mic and doing like that hasi. काय प्रॉब्लेम असेल तर सांगा बाबांनो. मला जर सापडला तर मग मला काही प्रॉब्लेम नसतोय म्हणा, नाही का. हॅलो, अनम्यूट करा सर्वांनी
No,
माईक.
sir.
जर कोणी चुकून जर
No,
सापडलं
sir.
एक्स्ट्रा ऍक्टिव्हिटी करताना अनोवेटेड काही मार्किंग वगैरे, तर मी तुम्हाला एकदा वॉर्न करेल, दोनदा वॉर्न करेल, तिसऱ्यांदा वॉर्निंग नाही देणार, ऍक्शन घेईल. टर्बो मशीन सब्जेक्ट हा वाटतो तेवढा सोपा नाहीये तुमच्यासाठी. तुम्ही बाकीचे जे तुमचे सिनियर्स आहेत त्यांना विचारा, कारण की ही जी आपण ऑनलाईन वरती बघतोय याच्यामध्येही तुम्हाला म्हणजे मे बी किती पर्सेंट तुमच्या डोक्यात जातं हे तुम्हालाच माहिती. हा सर्व प्रॉब्लेमॅटिक सब्जेक्ट आहे. तुम्ही सिरियसली घ्या त्याला. काही प्रॉब्लेम असतील तर मला विचारा ना. आता हे 5 मिनिटं आहे, तुम्ही विचारू शकतात मला, सर हा असा प्रॉब्लेम आहे, तो प्रॉब्लेम आहे, किंवा तुम्ही प्रॉब्लेम सॉल्व्ह करून बघा. 95% प्रॉब्लेम्स आहे या सब्जेक्टमध्ये. ठीक आहे, नो प्रॉब्लेम. अटेंडन्स लिंक ओपन केली आहे, अटेंडन्स मार्क करून घ्या. ओके,
Yes, sir.
थँक्यू.
Yes, sir.
Thank you, sir.